Imagine training a text-to-image model to generate perfect, detailed artwork, but the only feedback it gets is a single score at the very end. That's the reality of current reinforcement learning methods for diffusion and flow-based models. The model learns from the final image, but the path it takes to get there, every step, every decision, remains largely invisible. This leads to a critical problem: reward sparsity. In standard approaches like Flow-GRPO, the reward from the final clean image is simply propagated backward to every denoising step along the trajectory. But here's the catch: this creates a misleading signal. A step that locally degrades the image, say, by introducing noise or distorting a key feature, might still be rewarded heavily if the final output turns out to be good. This misalignment between local action and global outcome undermines the model's ability to learn fine-grained, coherent improvements. But what if we could assign rewards not just to the end result, but to each individual step, with a signal that reflects only the incremental effect of that step? What if we could detect those pivotal moments, where a single denoising action flips the trajectory from going downhill to heading toward a better final image? Welcome to TurningPoint-GRPO, a new framework that fundamentally rethinks how we assign credit in flow-based reinforcement learning. Let's dive into the core insight. The problem isn't just sparse rewards, it's misaligned rewards. When you sample a trajectory using a stochastic SDE-based denoiser, each step introduces randomness. But the final reward only reflects the aggregate of all those choices. So if two trajectories end up with similar final scores, the model gets the same advantage signal at every step, even if one trajectory had a bad local move that was later corrected. We visualize this in Figure 1, multiple trajectories, each with a reward curve computed by completing the remaining steps with deterministic ode sampling. The reward doesn't monotonically improve. It oscillates. It dips. It spikes. Yet in standard Flow-GRPO, every step inherits the final reward, so a step that degrades the image locally gets rewarded just as much as one that improves it. This is step-level reward sparsity, and it's a major bottleneck. So how do we fix it? Our first innovation: stepwise incremental rewards. Instead of assigning the final reward to every step, we compute the difference in reward between two states, one where we apply the current SDE step, and one where we don't. We do this by caching the intermediate latent, then running ode sampling from that point forward, which gives us a clean, deterministic estimate of what the image would have been without the current stochastic update. The difference between these two rewards, the gain or loss from that single step, becomes our incremental reward. This is the pure local effect of the denoising action, stripped of global bias. This tiny change has a massive impact. Now the model learns not just what to do, but why, because each step's feedback is now aligned with its actual contribution. But we're not done yet. There's a deeper, more subtle issue: implicit interaction across steps. In flow matching, each denoising step doesn't just affect the immediate next state, it shapes the entire downstream trajectory. An early decision might seem unimportant, but it can steer the model into a region of latent space where future steps are more likely to succeed or fail. We call these pivotal moments turning points. A turning point is a step where the local reward trend flips. For example, when a step that previously caused a reward drop now starts improving it. Crucially, this flip aligns the local trajectory with the overall trend toward a better final image. We define turning points mathematically. A step T is a turning point if the sign of the local reward change reverses and the new direction is consistent with the overall trajectory trend. This is detected solely via sign changes in incremental rewards, no thresholds, no hyperparameters. It's elegant, efficient, and fully automated. And here's the key: at these turning points, we don't use the local incremental reward. Instead, we assign an aggregated long-term reward, the total reward from that point to the end of the trajectory. Why? Because the impact of a turning point isn't just immediate. It's propagated. It sets the stage for future steps. By giving it a cumulative reward, we signal, this step matters not just for now, but for what comes after. This mechanism explicitly models the delayed, implicit interactions that standard GRPO methods ignore. It's the first time such long-term credit assignment has been integrated into flow-based RL. Now here's the beauty of the design: we don't need to tune anything. The sign-based criterion is robust. The aggregation is natural. The reward signal is denser, more accurate, and more aligned with the actual dynamics of the denoising process. We tested TurningPoint-GRPO across 3 challenging tasks: compositional image generation, visual text rendering, and human preference alignment. On compositional generation, where accuracy in object count and layout matters, our method produced significantly more precise results. Flow-GRPO sometimes added or omitted key objects, but TP-GRPO learned to preserve structure because the stepwise rewards guided it toward correct decisions at every stage. On text rendering, where OCR accuracy is critical, Flow-GRPO occasionally missed small words or caused character overlap. TP-GRPO consistently rendered text clearly and legibly, because the model learned to prioritize fine details at every step. And on human preference alignment, where aesthetics and content coherence are key, TP-GRPO generated images that better match the prompt, whether it was a fantasy city on Mars or a retro neon sign in a desert night. The layout was more logical, the style more consistent, and the details more faithful. Crucially, we didn't see any reward hacking, no artifacts, no unnatural distortions. The model learned to improve real quality, not just game the reward function. Training curves show another advantage: faster convergence. In one experiment, TP-GRPO reached the performance of Flow-GRPO at step 2300, but in just 700 steps. That's a 70% speedup, thanks to better, denser feedback. We also explored sensitivity to hyperparameters. The number of SDE steps used during training, the window size matters. Too small and you miss late turning points. Too large and you waste compute. But within a reasonable range, TP-GRPO consistently outperformed the baseline. Noise scale in the SDE sampler also plays a role. Too little noise and trajectories are too similar. Too much and the signal becomes unstable. But again, TP-GRPO showed robust performance across a wide range, proving it's not just a sensitive trick, but a principled improvement. And for the first step, where our turning point definition naturally excludes initial actions, we added a simple constraint. If the first step aligns with the overall trend, we treat it as a candidate for long-term reward aggregation. This ensures no early decision is left unmodeled. So, in summary, we replace sparse, outcome-based rewards with stepwise incremental rewards, isolating the pure effect of each denoising action. We identify turning points, steps that flip the local reward trend, using only sign changes in incremental rewards. We assign these turning points an aggregated long-term reward to capture their delayed impact. And we do all this efficiently, hyperparameter-free, and without breaking existing frameworks. This isn't just a tweak. It's a shift in how we think about credit assignment in sequential generation tasks. It brings reinforcement learning closer to how humans learn, not by judging only the final product, but by understanding the journey, the small choices, the pivotal moments, the long-term consequences. TurningPoint-GRPO is more than an improvement. It's a new paradigm for aligning generative models with quality, coherence, and intent. If you're building or training text-to-image models, this is a game changer. The code is open source at github.com/yunstong/TurningPoint-GRPO. Go check it out. And if you found this insightful, hit like, subscribe, and stay tuned for more deep dives into the cutting edge of AI research. Because the future of generative AI isn't just about better models, it's about better learning. And that starts with better feedback.